Hi, thank you for watching this Connect with BMC Helix ITSM and Remedy webinar. I'm Doug Reif, Principal Technical Support Analyst with BMC Software, and today I'm working with my colleague Kent to present Understanding the Best Practice Configuration Recommendations for the Remedy ITSM Platform Solution.
And I'm Kent Dillard. I'm a lead product developer, and most of my work has been with AR System Server. Today we want to start out by talking about why are there performance issues. So I have a few things to discuss with you on that. And then from there we'll go on to what can we do to resolve these performance issues. And following that up with some specific BMC recommendations and some specific tuning steps that we can do in the BMC ITSM platform. And then towards the end, we'll discuss the best practice recommendations that BMC has identified as the best starting points for the AR System Server. And then at the end, there will be some references. We want to ask the question, why are there performance issues? And I've got a list here of things that we see do cause performance issues. And one of those is the hardware specs are not sufficient to meet the requirements. And so it's important to know what your requirements are. BMC has done some testing, and we have documented what we think are initial requirements that are a good place to start, and we'll mention those later. Another part of this is that the components in the system, the various components that we reach, like the database layer or the mid-tier layer, each one of those need to be tuned as well. And we might have a good AR server tuned well, but then the mid-tier might be seeing some problems. So we want to remember to look at each component when we're looking at performance issues. One thing that sometimes happens is initially the environment was very good for the design specs and things worked well, but over time things grew. Something increased, the size of the data or the user base increased, and now the environment is too small to handle the load. So sometimes we need to look at that and find out what changed over time. There are some cases we see where a user or a process performs an expensive activity. It might not be a wrong activity, but what it does is it ends up running a query or performing an operation that's very expensive. So we need to look at those too sometimes and decide, do we really want to do that? Can we change it? Things like that. And then the last thing here is a third-party interaction. There could be some things going on the system that are outside of the specific BMC environment, but they're still on the same hardware that use resources or do things that slow things down. Sometimes we've seen a virus scanner cause a problem like this, or there might be another process that's using up CPU resources, and this can cause problems. Once we do find a performance issue, what can we do to solve that, or what can we do to avoid that in the beginning? And that's what the first point here is about, planning ahead. Sometimes you can avoid running into performance issues if you keep an eye on what you have planned and make sure that as you plan to roll out new things or add new things to the environment, as you do that, you understand the hardware that's needed to do that. And one thing you can do to keep an eye on that is do load testing with good representative test cases that can help show what's going to be needed when this actually gets rolled out. One key thing to do is frequently monitor the system and the network resources. Make sure the hardware that's there is keeping up with the workload. And if you do see something there, then that's the time to start looking more closely at that and decide, what's using up these resources. When you keep a good monitor going on and watching what's happening, it would be easy to identify what's competing for these resources. As these things come up and we see things that are using the resources, they need it, you don't want to turn those things off. Sometimes there's some tuning that needs to be done. This environment that BMC provides is an OLTP environment. It's dynamic. People use things each day differently. Things change over time, and it's a good idea to keep an eye on what's going on to make sure that the resources that we do have and the system is tuned to keep up with those changes. And the JVM is the Java environment that also needs to be watched to make sure that the processes that are running inside that JVM have enough of the CPU and memory resources. As the needs change over time, the JVM would need to be tuned to keep up with those needs.
So what does BMC recommend? First of all, BMC recommends that you have a properly sized database. Sizing a database server for capacity is important because it might not be feasible, or you might not have the finances to scale the database horizontally later on. So make sure up front that your database is sized properly. It's also essential that you have a fast database I/O. So much of what AR system does, the normal work throughout the day, is all database centric. So having fast database I/O is really critical. And having high-speed access to the database is also critical. The AR system only really caches in metadata, so all the other data, transactional data, saving records, loading records, all of that is highly dependent on having a fast, reliable, low latency connection to the database. BMC recommends a gigabit connection with close to zero latency between the AR system server and the database. Any additional hops or packet screeners or any other network device between the AR system and the database is going to have a negative impact on performance. BMC also recommends that you scale horizontally. For AR system server tier, you can scale horizontally just by configuring more servers in your server group. For the web tier, you can scale horizontally by adding multiple mid-tiers connecting to the same AR server or the bank of servers in your server group. And you can configure a load balancer or a reverse proxy in front of the mid-tier to route the browser clients to the different mid-tiers. BMC recommends having a dedicated environment for the Remedy application. This means you don't put Remedy in the AR system and the different components on servers that are busy doing some other work. Performance is difficult to manage when you have other applications that are running on an AR system environment. It's also difficult to manage when you have different unsimilar Remedy components on the same environment. So it's real important to have dedicated environments and kind of isolate your work. If there's a load balancer or a firewall between the mid-tier and the AR system server, configure it so that idle connections from the mid-tiers are not severed. Reestablishing severed connection takes additional time, so we don't want to have to worry about that. So lastly, and probably most importantly, what BMC recommends is to use our best practice configuration. This is a starting point for performance configurations. So we have done in-house testing, and we've also used this configuration on many customers to prove that the configurations work in general and that they provide adequate performance. Now, based on your own performance testing, you might find out that some of these configurations need to be set more appropriately. But until you have done your own testing, we recommend that you start with the best practice configuration and use those as a guideline.
Okay, one of the components here is the AR system database. And the database, we want to make sure has enough of the CPU and memory resources to handle the load that's being passed to it, as well as the disk space and indexes that can be used to improve performance. The AR servers that are connecting to this database, we need to make sure they have enough memory and enough threads to handle the load that they're running. And the backend integration AR servers, it's still the same type of tuning where they do different work, but we still want to make sure they have the right allocated memory and number of threads to run. In tune with these AR servers, we're going to have the Java plugin servers. One of those we call the main Java plugin server, and there are a couple others here that get used also. And these in general would need to have enough threads to handle what load the AR servers are passing to it, and enough memory to handle the data that's being passed through these. After the plugin servers, the mid-tier is another component that we'll talk about tuning, and in particular with mid-tier, we usually need enough memory to handle all the browser connections that are going to it. It also has connection pools, and we want to make sure there's enough connections per AR server so that it can be balanced well with all the AR servers. The load balancer has a few settings that BMC has found that are useful when load balancing to mid-tiers. And then the end users, we talked about a little earlier, sometimes an end user can perform bad ad hoc queries. We want to make sure that users are trained well to run proper queries, especially if they're allowed to run ad hoc queries. And at the same level, we have the integration processes that come into our server and make sure that they've been programmed to run processes that are tuned well and work well with the indexes that we've defined in the system. Okay, Doug, so what are some of the specific tuning recommendations that we have for these components?
All right, so first of all, let's look at how we're going to tune and the environments that we're tuning. And what BMC has done is we've kind of separated our tuning advice based on the size of the system. We have 3 recommendations: small, medium, and large. So a small environment is an ITSM environment that has 800 or fewer users. A medium environment is generally an environment where there's 800 to around 2,000 users. And large is up to 5,000 users. And at the same time, we find that in most of these environments that if you have smart reporting, there's generally about 50, 100, and 250 users in the respective environments. Also, the number of managed devices helps weigh into the sizing. And typically in a small, medium, and large environments, you'll see 2,000 or fewer devices, up to 10,000 devices, and then up to 30,000 devices for the small, medium, and large. So that's how we're going to do the sizing. And the rest of the recommendations are based on those 3 sizes. So keep that in mind. As you're looking at this, you might quickly identify what size that your environment's going to be in, your production environment particularly, and then start looking at the recommendations for that size of environment. So first of all, we'll talk about the database recommendations. For small, medium, and large, we're looking at a VM or a physical environment that's 8 CPUs, 16 or 32, depending on the size. And the RAM will increase from 16, 32, and 64 gigs. The disk space is, it's roughly 200 gigs required just, to sustain the environment on each of the environments. So let's look at some Oracle specific settings. The memory target, if you're using Oracle 11G, which most of you are, is 8 gigabytes, 16 gigabytes, and 32 gigabytes. So you want to make sure that's set and that you have the memory, the physical memory, which you should at this point, to sustain that. Some other settings that we recommend, and I'm not going to go through every value, but you need to be cognizant of these values for the SGA target if you're using 10G. Which nowadays fewer and fewer people are using 10G. Make sure you check the DB cache size, the shared pool size, PGA aggregate target. One thing that's real important is the cursor sharing. This will play an important role. Now by default in any of our 9.x products or above, so 18.x and 19x as well, the cursor sharing should be set to exact, and that's because we use bind variables. And by using bind variables, exact is much more efficient. Now, having said that, there's an asterisk next to exact. And the reason for that is when you are using Oracle case insensitivity, we don't use bind variables. And because in that particular scenario, we don't use bind variables, you're going to want to use cursor sharing set to force. So this is documented. If you are using Oracle cursor sharing, you probably have seen a knowledge article that references it, and it makes it very clear that when you're using cursor sharing, use force. Also, something that we've seen over the years and we always recommend is the B-tree bitmap plan should be set to false. Now, if you're using SQL Server, there's a couple things that are kind of similar to some of the Oracle ones. The parameterization is generally recommended to be simple. It seems to provide better performance overall. One thing that's really important to set on SQL Server, and it's not there by default as far as I know, is the read committed snapshot. That should be set to on. If that's not set to on, you could end up with some database blocking issues going on. So the next component we want to look at are the user-facing AR servers. And the user-facing, of course, is going to be all your end users performing your typical work throughout the day, saving and querying and creating new records. And what we recommend in a small environment is that you have at least 2 servers. Even in the medium environment, we recommend 2 servers, but having more CPUs. And in a large environment, we recommend having at least 3 servers for your user-facing. And you can see the memory requirements here as well. They go up, and so in a large environment, you'll want at least 32 gigs of RAM. For the Java settings are real important. Now, out of the box, they may be adequate, but for each of these environments, make sure you look at a minimum, look at the heap size. So the heap size for small, medium, and large is 6 gigs, 8 gigs, and 20 gigs. And those again are based on testing. If your size is somewhere between a medium and large, you don't necessarily have to go right to 20. You could use some variable in the middle there. But these are the basic recommendations, so take a look at that. Also, the GC settings and the other Java-specific settings are probably there out of the box. These are set in the arserver.config file, but you do want to make sure that these are set and they're set appropriately. And these are the same for small, medium, and large. The next thing we want to look at is the fast and list queues. That's really important in a user-facing environment to make sure that your end users have enough threads. So take a look here at the small, medium, and large environments, and notice that we have different sizing recommendations. It is important that you look at these and set them appropriately for both the fast and the list. We also recommend here the loopback or private socket queue. 390626 is a specific queue that's used by some plugins to connect back into AR server. And we want to make sure that if any plugins are connecting back into AR server, that there's enough threads to do the work. The next thing we want to look at is the backend AR servers. Now these are going to have slightly different requirements because you won't have so many end users needing so many threads, but you're going to have other queues doing work and integrations that need enough threads to perform their work. So back to the sizing, for small, medium, and large, we recommend having 2 servers in each environment. Now, depending on your environment, like for example, if you're heavily using FTS in a SmartIT environment, you may very well need more than 2 servers. So, a lot of this is just the basic recommendations, unless you have a better idea. And depending on each of your environments, there's going to be some variables. Again, with the Java settings, make sure that you're set appropriately with the sizes. And now you're going to see a lot of specific recommendations on different queues. For FTS, if you're using FTS, and most customers that have an ITSM suite are using FTS, and so make sure that you have enough threads. We recommend 3, 5, and 7 threads respectively for small, medium, and large. The reconciliation queue, we recommend setting that to 390698 and then setting the number of threads to 2 and 4, 2 and 4, and for large 2 and 8. The CMDB RPC normalization queue and the AR RPC normalization queue are both queues that the normalization engine uses. Normalization engine, if depending on your environment, can get quite busy. And one of the things that we do here is set it with enough threads, but not too many threads, because if you end up assigning too many threads, you could end up taking up too much CPU time for normalization jobs. Now, the list and the fast queue, we know they're not going to be as heavily used in these environments as they would be in the user-facing environment, but we still have the recommendations to set these larger as your size grows. One thing to note is if you're not using these threads, that's not a waste of resources. So if you're thinking, well, I only have 10 users on this environment, I'm wasting threads, we don't really see that as a waste of resources. So go ahead and use the recommendations unless you have a better idea for your personal environment. Again, we recommend setting the loopback queue just to make sure that the plugins have enough threads to connect back in on. We do recommend using CMDB inline normalization set to true. The alert queue isn't often used much anymore, so leave that at 1. The escalation queue, now this is something interesting, is the escalation queue, there's only one size. The min and the max need to be the same because escalation threads don't increase as the work increases. So how the escalation queue gets used is by how many pools you're actually using. So what's understood here is that in a medium and large environment, that you actually have assigned some of your escalations to different pools. If you have an environment where you've never assigned any escalations to any pool other than a pool 1, then having 9 pools or 9 threads isn't going to help you. So just know that if you're in a medium and large environment, if you're increasing the number of threads for these pools, then you also need to go and look at your escalations and make sure that some are assigned to those pools as well. And approval, we recommend having 2 threads for each of the sizes of environments.
Okay, for all of the AR servers, we have some common recommendations, and these settings are out-of-the-box settings, so they should not have to be set. If you want to change them, you can, but our recommendations are The max entries per query is 2,000, and this keeps the result set from being too large, so when the AR server sends results back to the clients, it's not using a lot of memory at the RPC layer. We have the next ID block size set at 100. This helps reduce contention on the AR schema table when creating new entries. The server-side table's chunk size at 1,000 is for filter processing that steps through table fields. The chunk size keeps the memory use smaller, and if there are more than 1,000 records in the table field, then it would be a multiple chunk filter processing. And again, that's just to help reduce the amount of memory used. Allow unqualified queries. We generally want to set that to false. We don't want users just running unqualified queries to get all of the data at the same time. Our authentication chaining mode of 1 is intended to authenticate at the user form first. That's where most of the users are going to be authenticated in most environments. And then if needed, the server would go out to area to do some external authentication for certain users. For the server plugin default timeout, we want to keep that at 120 because the plugins that are called during create entry and set entry, if they're not responding well, they take longer than 2 minutes. This timeout would keep that fast thread from being too busy for longer than when the client stops waiting. And if that happens too much, then you'll have fast threads all busy and your server would stop responding. And the last one here is the external authentication return data capabilities. And this value is intended to use area only for passwords. Now, of course, if you want to use area for other data like email address or the notification type, then this value would have to be changed. Okay, for our Java plugin servers, for the main Java plugin server, you would want to set the number of core threads to 30. And this is our initial recommendation, and it's the best recommendation that we've seen in all of our testing. We would go to the plugin server configuration form, and there's a picture here that shows you would choose the server instance for the 9999 plugin, which is our default port. And then on that screen, there's the number of core threads over on the right, and that would want to be set at 30 for the main plugin server. For the CMDB plugin server, we want to set the same number of core threads, but for that one, we want to set that one at 10. And this is the plugin server that runs on 9556. Okay, the FTS plugin server, for the small, medium, and large, we also want to set that number of core threads, and it would be 10, 12, or 16. And this is also set on that same form where we would pull up the plugin server for the FTS plugin running on 9977. Now there are some memory size changes for the heap and some GC settings that we would want to make sure are set for this plugin server. And these GC settings, you'll recognize these. You have the same settings in AR server that we talked about earlier. To set this for the FTS plugin server, we want to edit the AR monitor config file. And there's a line here that's highlighted that shows the -XMX, which shows the size of the process. And this is 4 GB for a small plugin server. And then the GC settings in the green highlight there, we want to make sure all these are spelt that way on this line so that that server will use these GC settings. I want to mention something about the size here, the -XMX setting. For the other plugin servers that the AR server runs, they also have a command line in the AR monitor config file. And if you find you need more memory for these servers, this same value would be set on those plugin server lines.
Okay, now let's look at the mid-tier load balancer recommendations. First of all, it's important to know there's 2 network segments. There's the segment from the client browser to the load balancer, and then there's a segment from the load balancer to the mid-tier Tomcat cluster. For both network segments, we recommend that HTTP Keep Alive be turned on. If the Keep Alive feature also supports the optional values like Tomcat does, then we recommend using the settings in this table here, which is the Keep Alive count should be set to 5,000 and the Keep Alive timeout to 60 seconds. For the load balancer, we recommend the load balancing scheme of round robin with HTTP session binding cookie insert. So if you have set up load balancer at all, or if you have a load balancer admin you need to communicate with, let them know that you want to use round robin with HTTP session binding cookie insert. Now, if you are going to use your load balancer to detect if a node is alive, we recommend using HTTP monitoring and use a get on the following URL, the ARSys shared images background image GIF. So you can just use that URL, and if you can access that or not, we'll let you know if the node is alive. So let's look at some of the sizing recommendations. For the small, medium, and large, we recommend 2, 2, and 5 servers in these environments. Now, obviously, if you're somewhere between a medium and large, somewhere in there you may have 3 or 4 servers. We recommend the different XMS sizes here, 4 gigs, 8 gigs, and 12 gigs, and the standard GC and Java parameters here. For the Tomcat, the server.xml settings, we have different recommendations. The max threads is going to change. On small, we recommend 1,200, and then on a medium and large, we recommend 2,000. The rest are pretty much the same for small, medium, and large. The logging.properties file, we have recommendations to set the logging to severe. And then for the config.properties, we recommend setting the max connections per server at 150 for small, 350 for medium and large. Now for SmartIT, we have some recommendations as well. So you can take a look at the sizing for the CPUs and memory. And normally, if in a small environment, it's 1. In a large environment, it's up to 3 servers. And again, that could change depending on your specific needs. And notice the memory requirements of 6 gigs and 8 gigs. And notice the U-limit setting. We recommend setting the U-limit for N at 21,000 or higher. And then again, for the different sizes, we have max threads of 1,200, 2,000, and 2,000. So those are the recommendations. You can refer to this documentation when you're getting ready to size, so you have all the numbers available. That brings us to the summary. So today we talked about the best practice configurations and how they provide a starting point for configuring your environment. We do recommend that you do your own testing to ensure that you're properly sized and that you have the proper configuration. So don't just take these best practices as the last word on the topic. Make sure you do your own testing and make sure that you're using the best sizing practices for your environment. And use representative test cases. Make sure that if you're doing load testing or you're doing some kind of functionality testing, that you actually are using representative test cases. Don't just do something simple. Do the things, the activities that users and integrations are actually doing, and try to use a size and a load that actually represents your environment. And so based on that, along with the best practices recommendations you saw here and with your testing, you should be able to set up a well-tuned environment. And now we've provided a page of references for you. First of all, the performance tuning doc is in our documentation, and there's a lot of information about how to tune, best practices for tuning, how to do sizing. There's quite a bit of information there. I recommend that you go and take a look at that link. The configuration checklist is a lot of what we talked about today, and that's available as a document on the communities. And we also have a sizing and deployment guide available for you to look at. So take a look at those, and hopefully that you're able to get your environment sized properly and have good performance. Thank you for attending today.